All right, guys, welcome to your first video of the year. Like we talked about in class, the goal here with the videos is that you have an opportunity to learn no matter what circumstances come up this year, whether you're sick and having to stay home, if your family's sick, so you're having to be quarantined, if the whole state is sick and the school or the state decides that we need to close schools for a little while, whatever situation comes up, you are in a habit of learning from videos. And so when you're stuck at home, if you're stuck at home, you can still learn and you can still keep up with the class. So what we're going to do to start with is we're here at the beginning of the year, we have quite a bit of review these first few weeks. And that really is leading us into some pretty heavy topics that are coming up. So the concepts that we're going to go over today is stuff that you've already seen. It's stuff you've already learned, but it's stuff that I need you to get really good at. Later, we're going to be doing problems where you don't want to get stuck having to think through this material because the rest of the problem is what we're going to be focusing on. So the goal here is to remind you of the stuff that you've already learned. I'm going to give you a whole bunch of examples that you can copy down in your composition book and refer back to when you're doing the homework. So that here in a couple of weeks, when we start doing the new stuff this year, you don't have to think about this anymore because you've just got it down, you've got it figured out. So the first thing that we need to review is multiplying numbers with exponents. And in case you've forgotten, if I have any number or letter A, and up here I've got a little number or letter, the number at the bottom, the big number, is called the base. And that number at the top is called the exponent. That little number at the top is what I mean by exponent. So this year, we're going to be multiplying numbers together quite a bit that have exponents in them. So when you have those exponents, you need to remember step one here. You can only multiply numbers or variables together that have the same base. So go ahead and put base in that box for me. You can only multiply these together if they have the same base. And this isn't anything new. You've already learned this. You've already learned that if you have 3 and you have x, you can put them next to each other. You can say 3 times x, but you can't actually, we don't know what x is, and so we can't combine it with 3. So this isn't anything new for you. The only difference is now, instead of just 3, we're going to have 3 squared. And instead of just x, we're going to have x to the 4th power. The bases are different, so we cannot combine these two together because our base over here is a 3 and our base over here is an x. If this was x squared multiplied by x to the 4th, that's okay. We can do that because the base is both x. If it's 3 to the 4th power and 3 to the 7th power, that's okay because both of our bases are 3. And it doesn't matter what the base is. The base could be something ridiculous like 0.003 raised to the 2nd power and another 0.003 raised to the -5 power. It doesn't matter what my exponents are. As long as my bases are the same, we can combine those together. We can multiply them. Now, how to do that mathematically? I'm going to give you a formula that you can refer to, but hopefully the examples help a little bit more than the formula. You've got to leave the base the same, but you add the exponents together. So write that down, and then I'm going to show you what that looks like. You leave the base the same, you add the exponents together. So working with some of these examples up here, x squared multiplied by x to the 4th, they both have x as their base, so I can multiply those together, but I leave the base the same. X stays x, and I add the exponents. So the 2 and the 4, I'm going to add those together to equal 6. So that's how I combine them. And it doesn't matter what my bases are. The base stays the same. It doesn't matter what my exponents are. I just add them together. I could have something like x to the -4 multiplied by x to the 6, and I still leave my base the same, and I add my exponents. -4 plus 6 is a positive 2. So that one would be x squared. Now the formula, what it looks like is if I have a raised to the n multiplied by a raised to the m, my answer is going to be a to the n plus my m. So that's what the formula looks like. I don't expect you to memorize it, but I do expect you to be able to use it. Okay, so it'd probably be a good idea to have those written down. But remember, we can only do this with bases that are the same. We can only combine them when the bases are the same. So let's do one more example. We keep using x. Let's do something like 7 to the 7th power multiplied by 7 to the 4th power. Now you could plug this in your calculator and get an actual number, but it's going to be a big, ugly one. And I just want to simplify. So my base stays 7, and I add the 7 and the 4 together to get 7 to the 11th power. All right, so that's, again, something you've seen before, but I need you to get good at it. So there's going to be a bunch of practice problems that look like this. I think there's 5 or 6 of them on the homework assignment. Just this same idea. Add the exponents together. Then we go a little bit step further. If you have more than one type of base, this is step 3 here. Like, let's say I have 3 times x squared, and I'm multiplying that by 4 times x to the 4th. If I have a situation like this, I can combine everything with the same base together. So I can still simplify this, but I have to just put things that have the same base together. So I have a 3 being multiplied by x squared, which is being multiplied by 4, which is being multiplied by x to the 4th. Now, since this has an x and this has an x as its base, I can combine those together by adding the exponents. So those combine to be x, and I take the 2 and I add the 4, and that's x to the 6th power. But then I'm left with this 3 and this 4. I can combine those together too. You know that. You know you can do 3 times 4. 3 times 4, that's 12. So I can just put the 12 in front. We like to put the constants in front of the x's when we can. So 12x to the 6th power is how that would simplify. Okay, so let's look at another one. Let's say I have -4x to the 4th power, and they want me to multiply that by 6 times x to the, let's add a negative up here just for fun. And then let's say it wants, well, let's do that one first. We'll start there. We don't want to get too much all at once. So -4x to the 4th, 6x to the -2. So this just means -4 times x to the 4th times 6 times x to the -2. So what I want to do is combine what I can. The number -4 and the number 6, those are called constants. I can combine those together. -4 times 6 is -24. And then x to the 4th power can combine with x to the -2 power because they both have a base of x. So this becomes x, and then I add my exponents together. 4 plus -2 is just 2. So my answer is going to be -24x squared. That's my final answer. Okay. Now this can get, I mean, we can keep going and going with this. We can add more and more things together. So let's do one more. I'm going to change the color here so it's easy to tell the difference. Let's do 3x to the 7th multiplied by -2 y to the 4th multiplied by, let's stick with some smaller numbers here to practice with. We'll do 4x to the -4th power. So when I write this out, everything's being multiplied. So this is just 3 multiplied by x to the 7th multiplied by -2 multiplied by y to the 4th multiplied by 4 multiplied by x to the -4. Now I'm looking for things that are the same base. 3 negative 2, and 4, that's probably the easiest to start with. So 3 times negative 2 is negative 6. And then times that by 4 is negative 24. So my 3 is done. I'm done with the 3. I'm done with the negative 2. I'm done with the 4. Now I've got x to the 7th power. That's not a negative. That's a multiply. X to the 7th, y to the 4th, x to the negative 4th. Now my x's can go together because they have a base of x. But my y is all by itself. There's no other y's, so I can't combine it with anything else. So let's go ahead and just put the y down here, y to the 4th. So we're done with this one. So now I just have x to the 7th and x to the negative 4th. So when I combine those, remember I have to add the 7 and the negative 4. 7 plus negative 4 is 3. So that's x to the 3rd power. And that would be my final answer. Okay, so if they have the same base, you can combine them. Just make sure that you add the exponents together. All right. So next topic for the day, actually the only other topic for the day, we're just going to cover 2 things, is what happens if we have exponents with more exponents. For example, what if I had something like x squared in a parenthesis, but then it wants me to take that to the 4th power. So I have an exponent with another exponent. If you're trying to exponent a number that already has an exponent, you have to multiply the exponents together. You have to multiply these exponents together. But remember, you keep the base the same. So what that looks like, with this example, if I have x squared and it wants that raised to the 4th power, then I keep the x the same, but the 2 and the 4, I'm going to actually multiply together to be 8. Okay, let's do another example. What if I have negative 4? Whoops, I need an exponent. Negative 4 raised to the 5th power, and then they want me to raise that to the 7th power. So I have negative 4 to the 5th raised to the 7th. Well, my negative 4 stays the same. My 5 and 7, I'm going to multiply those together. 5 times 7 is 35. So that becomes negative 4 to the 35th power. So the base stays the same. The exponents get multiplied together. All right. So what the formula for that looks like, for those of you that like formulas, if I have a raised to the n, and then I want to raise all of that to the m power, that's going to equal a raised to the n times m. You just multiply those together, keep the base the same. All right. Now, of course, we got to get a little bit more complicated because you've seen that, you've done that. We've got to add just a little bit to it this year. So if there's no plus or minus inside the parentheses that has an exponent, remember that you can distribute, and I'm going to put that in quotations because I don't know if distribute is necessarily the best word, but I think it fits with what the word distribute means to you in your head. I think it'll fit what we're trying to do here. So remember that you distribute the exponent to everything on the inside. Well, that was a whole bunch of mumbo jumbo. So what that looks like, instead of just an x squared inside the parenthesis, what if it was a 3x squared? And then the 4th was on the outside. Well, there's no plus or minus inside the parenthesis. So what that means is I take this 4 and I distribute it to the 3, and I have to apply it to the x squared. So it has to go to both of them. And what that means is that 3 gets raised to the 4th power, and the x squared, remember, x squared raised to the 4th, I have to times those together, becomes x to the 8th power. And that's what my final answer would be. Okay, so let's do another one. What if I have 7y to the 7th, and I'm going to raise that to the 2nd degree? Okay, Well, no plus or minus on the inside, so that 2 can go to the 7, and it can go to my y to the 7th power. So the 7 is easy. That's just 7 squared. Y to the 7th, when I add that other exponent to it, I have to multiply the 7 and the 2. So that becomes y to the 14th power. Okay? Now, because this is 10th grade and we're trying to help you get ready for the ACT, they like to throw in things that scare you a little bit, like decimals and negatives and fractions, but really it doesn't change anything that's going on. Even if my number on the inside, let's say it's 0.25, and I have something like y to the 3rd power. Even if that's a decimal, if this is being raised to the 2nd power, there's no plus or minus. So the 2 goes to the 0.25, and that exponent goes to the y cubed. So that becomes 0.25 squared. You can square decimals. That's just like squaring any other number. And then the y stays the same, but y cubed raised to the 2nd becomes y to the 6th power. So that would be my final answer. All right. So what I would like you to do, I want you to take a look at homework number 1. There are about 14 problems on there, I think, maybe not quite that many, that just practice these basic skills. All of the homework problems are going to match an example right here from your notes. So if you took good notes, you're going to have examples that will match the homework problems that you're going to see today. So go ahead and do everything that you can on your homework. We will work on that in class a little bit, and as long as you're caught up, you'll work on that in math lab if you have some time available as well. And when you do get to class, we'll work. We're going to kind of answer questions. So in class, this next class period, we'll answer questions from the homework if you've tried it and you have any. And we'll also look at some problems that are similar, but maybe a little bit more complicated while we're here, and I'm here to help you out with that. So we'll see you in class.